Hi guys, I'm Mr. Martin Ongeti, a teacher of mathematics and physics. I've taught these subjects for the past 8 years, and I've lectured several units in various institutions. And for today, I would like to take you through calculus, which is one of the topics that is covered in mathematics, and it is covered partly in Form 4 syllabus, and Form 4 syllabus that is under the Kenya Certificate of Secondary Education. Part of it is also done under the IGCSE, that is the British system curriculum, and most part of this unit will be an introductory unit for the first year student at the university. So the calculus is very, very important because it forms part of the applied mathematics that we use in various areas. In this topic, I'll take you through the course outline first. Under the course outline, there are several areas that I'm going to look at. One of them being functions and mappings, which is the first part of the unit. These functions and mapping covers both the injection, surjections, and bijections. Then we also look at composition and inverse of functions, limits of functions, continuity, differentiations. Under differentiation, we are going to look at the first principle, methods of differentiations, and under these methods, we are going to look at when we have functions that have got sum, products, quotients, and we'll also look at the chain rule differentiation, where we are going to look at algebraic, logarithmic, trigonometric, hyperbolic, and exponential, and also inverse functions of single variables, parametric and implicit differentiations. Then we'll also look at higher order derivatives, applications of derivative, small change, rates of change, stationary points, curve sketching also, bits of curve sketching, equation of tangents, and normal kinematics. Based on these video clips, only this video clip will cover the functions, and then if you get interested in it, then you can follow me and get the other units. Otherwise, thank you, and I welcome you to this lecture. So let's look at functions and mapping. Functions and mapping. This is the first part of the topic. Functions. Under functions and mapping, I'll start by looking at function. What is a function? What is a function? So a function is a process or a relation that associates each element of X of a set X, which is the domain of the function, to a single element Y of another set Y, which we refer to it as the codomain. What do I mean? If we have an element X that is a member of a set X, and we have another element Y which is a member of a set Y, then the relationship that exists between these two sets is what gives us what we call a function. So that one gives us a function. Now, if we have a function, in most cases we normally represent a function with f, which is a relation which is normally denoted as y is equal to f of x. So whenever we'll be having f of x, just know in mind that we'll be talking about y. Now, a function can be represented in pairs, that is in form of x and also f of x, where f of x represents y on a Cartesian plane that can also be plotted when we do what is known as graphing. So let's look at some examples and how we can work out some function. So example, suppose we have two functions. Suppose we have two functions, that is f and g as our functions, both having domain as domain, and suppose one of them, like maybe f, that is f of x, square each of its members, so that we can write it as f of x is equal to x squared, and g of x doubles one of its members, so that we can write it as 2 times x. And then we can have maybe several values of x that can be plugged into it. For example, if I want to find f of 5, this one will give me 5 squared, which is the same as 5 times 5. This one gives us 25. Then we can also have g of 5, which will give us 2 times 5, which is 10. Then we can even look for other values of x. Like, let's say if we have our f of x where x is a, so this one will give us a squared, and g of a will be 2a, meaning 2 times a, and so on. Or we can as well have our value of x being a plus h, which is the same as a plus h squared. This one gives us a squared plus 2ah plus h squared. That is a squared, then 2 times a times h, 2ah, then plus h squared, which is that. If we plug it into g, we will have 2 into bracket a plus h, which will give us 2a plus 2h. So that is example based on the unknown values. Now let's look at another example. Given that, that is example 2, given that h of x is equal to x squared minus x, find the value of a, h of 10, b, h of negative 3, and c, h of t plus 1. Now let's look at the solution of this question. The solutions. So for the first bit, if I want h of 10, and remember our h into 10, which will now be 10 squared minus 10. This gives us 100 minus 10, which is equivalent to 90. That's good. Now, we are done with the first part. Let's look at the second part, which is our part B. In our part B, we have h into negative 3, which is, if we insert x as our negative 3 here, we have negative 3 squared minus negative 3. So this one gives us 9 minus, or minus here gives us plus, minus gives us plus 3, which gives us 12. So we'll have 12 as the answer for that part B. Then we can also look at part C. In our part C, we have h into bracket t plus 1, which is the same as, so wherever we have the x, we insert t plus 1. So here we're going to have t plus 1 squared, then minus t plus 1. So this gives us t plus 1